Welcome back to class. I am Akenya Denga and I remain your naval robotics tutor in this terrain. Today we shall be considering an important subject matter with respect to automatic night lamp. As you can see, my setup at this point in time is actually an LED that's actually light emitting diode. On switching off the lights in my present environment, this night lamp actually comes on. And on switching on the light back, it goes off. Trying it again, the same reoccurrence is actually very much evident. This establishes the fact that light only comes on in darkness, and once there is an The concept behind this particular phenomena is actually voltage division law. That is to say, a constant current will flow through these resistors, and based on the fact that the voltage, that is the potential difference between the ends of this particular circuitry, is meant to be the Ohm here. So the voltage across the different resistors will definitely be varied based on the resistance of the resistors that are connected in series. This is the particular circuit diagram schematic. Basically, as you can actually see, you have your battery, your 50K, that is your 50 kilo ohm resistor, and you have the LDR. The LDR at this point in time is actually the variable resistor. That is, the resistance of this particular light dependent resistor actually varies based on light emission, and it's actually being fed into a what? Into a transistor. The transistor is actually being triggered, that is actually being powered up based on the current which is actually supplied to the base of the transistor, and you have the collector being connected to the anode of your LED, light emitting diode, while the emitter is actually being connected to ground. The transistor for this particular experiment is actually C1815. As you can see, it has its emitter, collector, and the base. Let's get onto this right away. Now, I will be demonstrating how we actually get this end result circuitry, basically, based on the schematics diagram, which is actually being indicated on the screen. Firstly, I'm going to dismantle this and start from scratch. As you can see on your screen here, that none of the components are connected basically. Firstly, you're going to notice that there's a particular duct here, which is actually meant to supply our positive power supply, and it's actually for negative. So what we might want to do is just to impute this particular negative probe, which is actually the black probe, and we actually put the positive beside it here. Then next, we are kind of like having to follow the schematics diagram, which is currently going to be shown on your screen. We connect a 50K resistance. That is to say, you have this particular resistor being connected here. Basically, you have 50 kilo ohm. In order to ensure that you have a wide range of variation of resistance, we might want to kind of like ensure that the resistance of this particular entity, so that it will be sensitive enough, is quite large. If we should check, we would notice on our digital multimeter, as actually been shown on the screen here, you turn to this particular phase, which is actually showing that, okay, we are currently on the resistance phase, that is this here. So if you should measure the resistance of this resistor, you're definitely going to notice there about that is actually around 22 point something kilo ohm to what? 33 watts kilo ohm. Let's just try to check that. As you can see, you have there about what? 33.7 kilo ohm currently on your screen, which is not up to what? 50 kilo ohm. And I mentioned the other time that we might want to kind of like what? Connect in series, so that it will be able to give us what we anticipate. So first thing, I'll actually connect the first one. I then just try to put it here. Now, since they are in series, I connect another one. Based on the fact that I want this particular setting to be very much sensitive, what I might want to do is to make sure I actually connect up to like what? 200 kilo ohms, so to say. That means if I should connect these 6 times, it should give me thereabout that particular value. So I keep connecting from one point to the other until I obtain what I anticipate. And it's actually currently on the what? On the positive rail. As you can see that the positive rail is actually this rail here. The first one connected to this, connects this particular one at this point in time, connect to the third one, connect here, then on and on and on like that till I obtain my desired resistance value. So I connect this. Then the next thing I want to do is to check the resistance value. As you can actually see on your screen here, that okay, the resistance value will actually be read at this point in time. Now let's just try to see. The resistance value at this point in time is there about 164 kilo ohm. Now I think with this, I've been able to get quite a good resistance. Then the next I might want to do is to connect my LDR. That is to say, one leg of my LDR actually comes here. Then the other leg of my LDR actually goes towards ground, of which ground is actually the negative point of this particular what? Circuitry. Now, this is actually what? A transistor. This particular transistor has emitter collector base, as you can see on your screen here, which is actually currently being displayed. Now, emitter is the first, collector is the second, while the base is the third. But based on the fact that I actually want to access my base, of which this is the base, what I might just want to do is just to kind of like what? Make it face this particular direction, of which I have my base already being connected to both the 50 kilo ohm, as you can see on this particular rail, and also the what? The LDR, basically. Next, what I might want to do is to connect the emitter of this particular transistor to ground. So I just try to connect it. As you can see, it's actually what? Emitter, collector, and base. So I'll just try to connect this emitter here, which is actually this first one here. I connect it to what? To ground as well. So that means on this rail, I have both the LDR, one leg of the LDR, and also the emitter being connected to ground, basically. Then next, what I might want to do is to connect the anode, which is a positive leg of my LED, to what? To the collector. And based on the fact that the collector is at the middle, what I might just want to do is kind of open this wider a bit, so that one of the legs actually goes here, then the other one actually comes here, because it's connected to the what? To the collector of this particular circuitry. Then next, what I might want to do is to kind of like now connect a 1 kilo ohm resistor. Maybe in our next class, we shall be considering how to actually get resistor values based on color coding. As you can actually see, you have the band 1, band 2, and the last one is actually the what? The tolerance. So you having this at this point in time, I just want to connect cathode to what? To the positive rail of this particular breadboard. So I just connect. Now, my circuitry is completely done. But the fact is, it doesn't come on. That's tell you that this place is very much illuminated. So what I might just want to do is just to power off this particular bit. Getting my hand closer to this, you notice that the light comes on and goes off. Comes on and goes off. Comes on. That is, it senses the darkness and actually powers up accordingly based on the level of what? The darkness. So as you can actually notice now, so definitely this is what makes up our automatic night lamp. Based on these schematics you can see on your screen. So in other words, this is what makes up our what? Automatic night lamp, basically. But based on the fact that I had already kind of like, the place is quite dark at this point in time, you can actually see when I power up, this night lamp goes off, and you can see that it's quite dim. But when I actually just try to put my hand kind of close to it, the illumination actually increases based on the fact that it's sensing a dark face, so to say. So here is the principle behind your automatic night lamp based on light dependent resistance. Thank you very much. See you in our next class. It promises to be very much pragmatically inclined. And bye for now.